I've had my eye on this tree for some time. This is perhaps the last of the Mohicans, the oldest, largest Marri gum that I've seen in Western Australia to date. This tree is an ancient. Let's have a look. Here she is in all her glory. This is the only one of this age class that you'll see on this highway. This tree is the subject of my latest Arborage article. As a professional arboricultural writer, I have been writing on trees for 25 years. In a 30-year arboricultural career, this tree has to be in my personal top 10. As is typical of an ancient alpha tree, this tree is very squat. A past tension failure, central to the tree's crown, helped to subordinate her. Forest trees, by their nature, do not prioritize strength and longevity over competitive growth and reproduction. But environmental factors outside of them help to subordinate their crowns, so making them stronger, more longer lived, and more resilient. This specimen is very well optimized with a very low height in proportion to diameter. This truly is a very exceptional form. The most longest lived trees are those trees which have elongation trained out of them. Crown elongation is always best managed on the level of the terminal bud, as well as having an exceptionally good taper from the upper crown down to the lower crown. And she also exhibits exceptional buttressing, extending into what we call a woody cone or a bell bottom, akin to a giant elephant's foot. These attributes are typical of the most successful ancient trees right around the world. You can imagine southwest Western Australia prior to settlement seeing hundreds, if not thousands, of trees of this age class. Yet in this 87-kilometre stretch of highway, there is only one. We only need to pan out from this tree and just look around the skyline, look around at the trees in a 360 and to get a gauge on the age class of what is left. In part 1 of the article that I wrote on this tree, I estimated that she would be around 180 years old. But who knows, this tree could be as old as 400. There are no records on the Australian ancients. To make it easier for the observer to understand this piece, I've included some edited terminology from Treecast 10. But there are other categories. There's ancient tree. Ancient trees are just very old trees which have progressed to the last third of their lifespan. Then we have veteran trees. Veteran trees are trees which have been damaged by the environment or by their environment. Also, we've got veteran trees which they can be any age. They can be a young tree which has been snapped in half by a storm event. They can be old trees. Ancient trees can be veterans as well. But there's another term, there's a new term that I've actually created. I refer to this new category as the alpha tree. I see different species of trees, I see different genuses of trees, I see families which are generically have alpha tendencies, but we can actually train trees to be alpha. Everything that I talk about is based on what nature does. So when we look at a tree which has been pruned by the wind, has been suppressed over decades of wind blow, these trees become very squat, and they have these almost like a hedged canopy. And insects and birds do the same thing. They'll take out terminal buds in trees and set up the crowns of trees to be more resilient to standing up to wind events. A classic example over on the East Coast is the red cedar titmoth, a major problem and a pest of mankind's plantations. But in the wild, this organism takes out the terminals of trees and sets red cedars up to be alphas. The term alpha is ancient Greek for number one. I think of the alpha tree as the 1 in 10,000 tree. Those trees so resilient that they live the longest. As well as being alphas, I describe these Marri gums as being phoenix trees. A phoenix tree is a type of tree that can generate its body over an existing body. I mean, all trees do this to a degree. They're like Russian dolls. But Marri gums, as with a few other species, are actually able to generate their bodies over broken bodies or even fallen bodies. Without doubt, this species is one of the most adaptable that I've seen in my career. Though this tree clearly has a strong genetic code, without vitality, it would not be able to make these adaptations. Plant vitality is driven by sufficient air, water, and carbon. One of the big deals for me with observing this tree is observing its growing environment. What we have here is a very high species diversity of vegetation that naturally is associated with this tree. It is very much an Australian phenomenon that such poor soils have produced such high species diversity. And this is because of collaboration below ground and collaboration above ground with plants in association with the soil's microbiome, producing and sharing an abundance of nutrients, resources, and information. You can consider an ecosystem to be equivalent to a biological computer program, where all these different species are programmed for a shared resilience, where resources and their byproducts are all part of the wood wide web. Truly, artificial intelligence is nothing compared to nature's intelligence. Though this prompts me to consider what artificial intelligence would look like if it was programmed by nature's intelligence. As I have discussed, plants harvest energy from sunlight. This they embody and infuse into the soil. They share it with the associate microbiology below ground, and that biology then shares minerals and enables a greater level of water absorption through associations such as mycorrhizae. Though modern science is revealing that plants are doing more in ecosystems than just share nutrients, they're also sharing information to help program the surrounding vegetation in resilience. It is this tree's growing environment that I attribute the vitality and success of this tree getting to such an advanced stage. Though at this point, it's important to acknowledge that this tree hasn't got through completely unscathed. She does have Marri canker. This kind of a disease, to give it a human perspective, as could be compared to leprosy. This is a disease which causes a dysfunction in the outer and inner bark. It's a disease that can lead to wounding and the exposure of sapwood. At worst, this disease kills Marri gums, but only those growing in very desertified soil environments, or soil environments that lack biological diversity. Therefore, this tree is recoverable. So, as well as help provide energy to her forest mates, this tree is also very important for habitation for wildlife. Trees do not get hollows in them until the second stage of their lifespans. Young trees, like teenage trees, are providing zero in the way of habitation compared to a tree like this. This is another reason why we should be investing in such trees. To invest in a living pump, such as this organism, involves proactive arboriculture, or conservation arboriculture. This is covered in my playlist on desertification and oasification. The area where conservation arboriculture is needed the most is in support of trees like this. Trees and main roads are always a challenge. Australia, once famous for her treed avenues of honour, has over the last 50 years lost many. The expansion of the built environment is a major challenge to professionals like myself seeking balance between citification and oasification. A major part of why I am developing this education is to build a bridge between arboriculturalists and land custodians. Sadly, too many arborists defer to development as their paying client and sacrifice the green environment. It's easy to condemn a tree under the guidance of an expert. It takes far more grit to validate tree retention. Yet inspired by the old world timber getters who knew a good tree when they saw it, who often refused to fell certain trees, I seek to empower the individual to know the trees for themselves. Yet the fact is, as if by divine providence, this tree stands right on the edge of a highway, the last of her age class, with the hallmarks of the worthiest for retention. Yet though she exhibits the epitome of resilience, this tree is very vulnerable to the uneducated and vulnerable to the educated. Most service-based tree companies are industry-led, industry being about mechanization, economics and compliance. Unless given strict rules, industry has no regard for habitation, posterity or the natural environment. Historically, it was the professional that led the way. Yet now too many professionals have their voices stilled by industry. The fact that this tree stands tells me she was either exceptionally lucky or, as is more likely, a professional or two has had her back. Perhaps an oxygen bed was installed under the highway in proximity to her root zone, but that's more likely for the future than today. The fact that she stands with reasonable health right beside heavily compacted raised soil grade is a testament to the species diversity, a testament to the oxygenated fishes and associate microbiology that makes up the oasis that interfaces with at least 2/3 of her root system. In truth, with collaboration, we can have the built environment and trees. All they need from us is air, water, and biologically active carbon. That, and some genius engineering from the best professional engineers. As humanity moves into her witching hour with climate change, now is the time for collaboration. Now is the time for the professionals to come together regardless of the industry prerogative. Following on from this tree, I have another case study. This is on a Jarrah gum, Eucalyptus marginata. This one is a true alpha. Another specimen with the exceptional hallmarks of resilience, to help better acquaint you, the land custodian, with what these trees look like. In the meantime, I give you footage of the many different species in flower that I captured growing in association with both the Marri gum, the Brockman highway tree, and also Jarrah trees and Marri trees growing in Maslin Reserve in Bridgetown, Western Australia. This array of native species was actually taken from my Treecast on oasification, but it needs to be in this segment as a way of recording the kind of species that naturally associates in the poor soils that make up the southwest in Western Australia. It's this array of native species that are helping with the nutrient assimilation for the old forest trees like our Marri gum. This is all documented in the two-part article which is attached to the description on this video. Tree care for the land custodian, parts 1 and 2. Whether we look at this biological record as being a reflection of science or creation, I believe we need to understand that it is by no chance that such an ecosystem was manifested. It is the collaboration of these plants and the soil-root interface that supports the ancient trees in element-deficient soils. So when you see trees falling apart, limbs failing, branches falling, diseased trees, trees dying when still teenagers, that is a reflection of biological desertification in the soil. What trees need to live long is oasification. In support of your education, I have created a playlist on desertification and oasification. Moving on to the Bridgetown Jarrah gum, the Brockman Highway Marri gum. I salute you. In our first case study, with the Marri gum, we were looking at a tree which is an ancient, which is an alpha, and a veteran tree. This tree is neither ancient or a veteran. It has an unbroken crown. She exhibits one dead limb which has been naturally retrenched by the tree. This specimen is the best example I've seen of a naturally suppressed Jarrah. As acknowledged, a 1 in 10,000 tree. So what makes this tree so special? Its highly functional yet naturally suppressed crown. The tree doesn't prioritize strength and longevity over competitive growth and reproduction. Strength and longevity is a human interest and a human goal, especially for some of us arboriculturists who train trees to live longer. And yet training trees to be alphas is something which occurs in nature, and the driver for that is the natural environment. The wind does this, frosts, droughts, birds, insects, bats, and arborists. Anything which repetitiously targets the terminal buds sets trees up for subordination. As long as a tree can successfully photosynthesize, as long as a tree can continue to generate energy, then it's meeting a primary requirement. A tree with a subordinated crown can still successfully photosynthesize, yet it is far more storm resilient. Remember, it's elongation, poor diameter in relation to length, or poor taper, which leads to biomechanical failure. So coming to this tree, what we have here is optimal taper. Very little in the way of elongation. What we have here are the hallmarks for storm resilience. Some kind of environmental factor has set this tree up for subordination. A closer study reveals to me that there are burls in this tree. Burls are a kind of a woody growth that look something like a giant wart. Science has no real idea what causes them. I suspect that burls, like life belts, act as almost spot welds in crown structure, helping deal with compressive load. Though regardless as to what has caused the subordination, this is very desirable in a tree for long-term retention. You can see a kind of a stout limb with the dark shadow underneath it in this image. That dark coloration on the underside of the branch is an example of flexure wood, or wood which has grown and expanded, caused an expansion in the bark. On the side of this limb, the limb is exceptionally broad, far broader than it looks from the underneath. So even with this kind of a twist in the branch, this is actually very stable. Most certainly that twist has been created by the burls. Based on study of the body language of trees, flexure wood is reaction wood. These kind of reactive tissues are flexed to help generate greater strength. You have reaction wood formation on the underside of the branches, and on the top side, this is known as tension or compression wood, or sometimes known as supporting wood. Sometimes it even forms in helixes or spirals. Sometimes you can get 2 to 3 helixes of wood, creating a braid of reactive tissues which make trees exceptionally strong. Reaction or flexure wood is tree muscle. I have even captured this in harvested power poles. Because of the very durable, decay-resistant timber, cavitation in this species is not much of a concern. In this case, there's a beehive in this cavity. No matter which angle you view this tree, what we're looking at is a very dense crown, exceptionally well tapered, with a great leaf surface area for sun capture. These are all the hallmarks for the greatest longevity for the alpha tree. I encourage you to take a mental photograph of this tree and then go out into the forest and have a look at the kinds of elongation that forest trees have as a mechanism to recognize the worth of this specimen. Alpha trees are the ideal tree for the city environment. Alpha trees are the ideal tree for kindergartens, for parks, for any area where there's human habitation. These trees will live 3-4 times as long as their forest cousins. In the same way that the natural environment can train these trees, so too can arborists. But this means using arborists that are trained in being able to access the very canopy peripheries and using hand tools, even secateurs, to just target the terminal buds, to help set up the natural suppression that we see in nature. The focus of my accompanying article to this video, in part 1, Tree Care for the Land Custodian, Less is More, is on volume reductions. A volume reduction is aimed at keeping pruning cuts in the sapwood. Pruning cuts which cut too deep into a tree's crown cut into the heartwood. Pruning cuts which cut too deep into a tree's crown are known to oxygenate wood tissues, accelerating the decay process. Truly, chainsaws are all but obsolete when it comes to volume reductions. Yet 5 yearly volume reductions, carried out by a sensitive arboriculturalist, is all a tree needs to be set up for subordination. A 5% height reduction is equivalent to a 30% volume reduction. The ancient art of bonsai is a perfect analogy for training alpha trees. Following my early find with discovering this tree, I had to go and do a comparative study on a number of other Jarrah trees, just as with regards to the tree's root crown. Most older generation trees with this kind of body language would usually have, significant buttressing, which is a major hallmark of the tree's success story. A tree lacking buttressing, such as this one, is very often a sign that the tree has been buried under the raising of soil grade. But having looked at a whole range of Jarrahs, I recognise that this is an attribute of the species. Maybe as a result of this species and its exceptionally durable timber, that there is no need for this species to generate significant root buttressing. Not the case with the Marri gums, which generate very, very significant root buttresses in proportion to their body language. In closing on this video, I hope you've enjoyed this study as much as I did myself. If you're inspired, I encourage you to subscribe. I also encourage you to make comment. Producing video is new for me, so feedback would be very welcome. For those wanting to make a more detailed study on my work, I encourage you to see the articles on these trees linked under the description. I'm planning on running a series of workshops on conservation arboriculture in service to trees such as this. This video series has been created as a part of a business startup aimed at sharing education with the world. Though this is my 17th video, this is my first to be shared to the general public. I thank you for your attention.